Hi guys, this video is a tutorial for Unity. In it I'm going to show a complete game. It's a very simple game and it's designed to show something in particular, something that I've been struggling with. So I watch a lot of other people's tutorials, and one thing that I've seen over and over again is we always need to move stuff around on the screen. We need to move game objects, but there seems to be so many different ways of doing it. And I've watched I don't know how many tutorials and they're all very good, they all work. And the thing that was missing for me is that no one seemed to explain why they were using this method rather than that method. And just recently I started work on another game which is supposed to be a simple game of Breakout, and I got stuck again. I was getting weird things going on with the physics and I thought I need to get to the bottom of this. There's something I'm still misunderstanding. And so I decided to put together just a little game project that I could use to really dig into all the different ways in which you can move objects around on the screen. And so I've decided to do this as a tutorial because it's one of those things where if you really want to test your own understanding of something, teach it to other people. So that's what I'm doing. So I've learned a lot through making this little game, and I'm putting it out there in the hopes that it will help you too. What I've done is aimed as a beginner's tutorial, but I haven't explained every little thing because it's already fairly long. I've tried to focus just on the movement aspects, and then for everything else I've just kind of glossed over things very quickly. Now it's aimed at beginners, but it will be helpful if you've at least played around with Unity before and you know a little bit of C#. If you don't know C#, I would recommend Code Monkey's tutorial. He's done a big tutorial which is online on YouTube for free. I'm going to start by showing you what we're actually going to be building in this tutorial. So I've called the game Flood Drop, and the idea is that you control this little plane which is delivering supply crates to a kind of a village or city that's kind of been flooded. It looks terrible. That's kind of not really the point of it. What you've got 20 crates to start with. You've got to try to drop them, not like that, drop them on the actual roofs of the houses and try not to drop them into the sea. Once you've dropped all 20 of them, so that one has gone into the sea, so you can see there it's going up on there. Once you've dropped all 20 of them successfully or not, the game ends. So that's what we're going to be building. And what we've got on here is we've got several different things that move. We've got the clouds that move steadily from right to left. We've got the plane which can only move up and down. We've got the houses that move left as well, and then we've got the crate which is obviously dropped. And we've got the plane and the clouds are just regular kind of sprites, but the houses and the crates are physics objects. So this tutorial is going to be going into the detail of how to move things around the screen, all the different ways in which they can be done and why. So what I'm going to do now is I'm going to turn my camera off just to make sure that my face just isn't in the way of any of the actual code or anything like that. Okay, let's get into it. I'm going to begin by creating a new Unity project. I'm currently using version 6.0 of Unity, and it's going to be a 2D project, so I'm just going to use the core there. I'm going to call this game Flood Drop, and then I'll pause while this is building. Project has opened up, and this is the default Unity layout, which I'm not a fan of. Now I personally have got a layout which I use, which I call edit and play, and what I like to have here is I've got the scene view up here, and I can also see a preview of how it's going to look, and I've just got bigger windows for the game hierarchy and the inspector. Now the first thing I do with any kind of new project is I set up a few folders here, which I'm just going to do at the beginning. So I'm going to have one for all of my scripts. This is a 2D game, and so I'm going to have lots of sprites, and I'm also going to have a handful of prefabs. One more thing I want to do here is I'm just going to create a script in anticipation of something I'm going to do a little bit later on. Just going to call a script, so create a script called Game Manager, and I'm going to double click on it just to bring up Visual Studio. There's a reason why I've chosen to do this at the beginning. Something that I don't see mentioned very often is version control. So Unity offers its own version control, which I don't recommend. And what I usually do is I just click this hide version control toolbar. And the very first thing I do when I create a project is to integrate my project into Git and GitHub. Now, if you've not used GitHub before, I'm not going to go into detail in this video because it's not really the point of the tutorial. So Git is something that allows you to save different versions of your project at different times so that you can go back and look at how your code was before. So for example, on my latest game that I've been doing, Sprite Break, I've only just started it. I've got 14 different commits there, and I can have a look at any point, what I've done, what has changed in the actual code. And this allows you to just go back and retrieve code from before. It's very, very, very useful if you ever mess something up. So you can simply go to this github.com and create a free account. Once you've done that, if you've got Visual Studio, it is super simple to integrate it. All you do on a new project is you go up to your Git tab up here and you do create Git repository, and so it automatically has what I've the name of my project here, and there's something called a git ignore template. This is important because Unity has a lot of files which we don't want added. I'm going to scroll down here, just click on Unity. By default it pulls in all of my information, and by default it's private, which is fine. Game's called Flood Drop, that's fine. It's going to create the new repository and it's going to push it, which means it's pushing a version to it over to the web. Now if I come back over here, there we go, created new repository, Flood Drop. And then I'll just be committing that at various points in there. If you want some more information on Git and GitHub, let me know. I can do a video on that. So coming back into my scene now, one thing that I like to do is change the name of my scene. By default, the first one is called Sample Scene. Now what I like to do, if it's just a simple game, which this one is, I'm just going to rename it and I'm going to call it Game. Now in here, I've got a camera. What I'm going to do here is I'm going to change this to a lighter blue. And I've got a color which I handily saved earlier. I'm going to paste in there. And this is going to basically represent a sky for the game. Next, let me show you the assets that I'm going to be using for this. So they are all available for free to download. There's no cost here, and they're on itch. All of the links will be put on the itch page for this game. So the first one is actually Adventures in Visual Novels, but I'm just going to take this background screen right here, and in particular I just want the part that's going to be the sea. We have another asset here for some clouds, which we're going to just move across the scene. Then we've got some houses. Now these are convenient because they've got the flat roofs. That allows us to have an area on which to drop a crate. So I'm only going to be using a few of these. I'm not going to be using the ones with the triangular roofs. Then I have a train game over here, and all I want from this one is the crate sprites. And then I have a a plane pack here. I'm just going to be using one of the sprites from there just for the plane, which is going to be player controlled. And lastly, a font. This is a true type font called Bangers. I've used this in one of my previous games. It's free for both personal and commercial use. So I've downloaded all of these packs here. Obviously I'm not using all of them. So on this one, all I need here is that sea day. For the clouds, all I need is this one sprite sheet here with the transparent background. For the crates, I want this one here, crate big. For the houses, I've chosen the ones for the high level of detail, but both are fine. And I've gone for the Mediterranean look, not the evening. And I'm using house 0, house 4. 5 was actually too small. It sunk underneath the sea. It didn't pop over. House 7, 9 and 11. And for the plane, you can use any of the planes that you like, and the one I used was plane 2 and this yellow one. I've dropped all of those files into my sprites directory that I created under the assets, but now what I'll need to do is actually create an asset within Unity itself. So come over to my sprites folder, and now I need to change a few things on the import. Now what I've already done is I created a practice version of this project so that I could run through everything. So I already know the settings I need for importing all of these sprites. So I'm just going to give those to you just to make this a little bit quicker. The point of this tutorial is not messing around with the sprites, it's just getting the movement of the game. So I'm just going to run through this stuff as quickly as I can. First of all, I'm going to bring in this sprite here, which I'm going to be using for my water. I'm setting this to 70 pixels per image. Hit apply. Now if I drag this into my screen, this will now sort of take up the majority of the screen there. But the problem we have with this particular sprite is, of course, I don't actually want this top part because I want to put my own clouds in. So I'm going to use a little technique here. Instead of this draw mode of simple, I'm going to change this to tiled, and then I'm going to change the size of it. So what I'm going to do here is on the width, I'm going to set that to a nice round number of 18, but the height I'm going to make a lot smaller. I'm going to set this to 4.2, and as we can see, that just limits that to just the part of the sea. I'm going to change the Y direction there to -4, and that positions it at the bottom of the screen. Another thing I'm going to do here is set up the sorting layers for the sprites. So by default, all of the sorting layers appear on the same layer called default, and I'm just going to add a few of them in now. So I want a few here, so I'm going to have one for clouds. I probably don't need all of these, but because it's such a simple game, it's quite easy just to set them up. Houses. Now you might think it's a bit of a weird ordering, but what we want is the crate is going to begin by kind of being underneath the plane so that it looks like the plane is holding it. So the plane needs to be drawn over the top of the crate. And the water in particular, the idea is that the water is flooding the houses, so the houses need to appear behind the water, but we want the crates to go over the top. It shouldn't actually go over the houses, they should just kind of like bump into each other, but I found that this layout works quite well. So come over to the water object, and don't forget to actually change the sorting layer to water. Next, I'm going to work on the cloud sprite. So this is a sprite sheet. So I'm going to do this. I'm going to leave that on multiple. Now I need to make that a little smaller to 70. But what I'm also going to need to do that, if I just apply, is on the sprite editor, I need to actually slice this up. So by default, it tries to identify what the clouds are. But with this particular image, there are some overlaps. So ones which are overlapping. So if I take this one here, that would include this little piece here. So I'm going to delete that one. I'm going to delete this huge one because that's got this piece here. I'm also going to delete this one simply because when I was testing, I found it's very similar to that one there, and it's the invert of that one. And I think all of the others work nicely in isolation. That will do, just need to apply, and that's done. Next, I'm going to work on the houses. Now, for some reason, on this particular asset, the different houses actually come up as being different sizes. I'm going to drag each one of these just into the scene so I can kind of see how it looks. And you'll see that there's some which are a little bit too big. House 0, I can leave that one alone, but we need to change that to singles. So 100 PPU is fine. For house 4, 100 PPU is fine, but change that to single. House 7, 100 PPU is fine. But house 9, I found that worked better with 150. You notice they're disappearing. That's because the sprites are changing. And number 11 on single, and this changed to 170. I can just go and put the sprites back on here because they're missing. Now we don't actually need these for the game because we're going to make these all prefabs a little bit later. But it just helps to visualize how the game is going to look. Now there's one quite important thing that we need to do actually. and that is to change the pivot of the sprites. By default, all sprites will have their pivot point set to the center. So if I zoom in a little bit, we can see that on this house, where I'm dragging, the arrows here are showing the center of the sprite. But what I want is I want them all to line up as like the bottom of the sea. So what I need to do for each one, I need to go open up the sprite editor, and on the pivot here, instead of center, I just need to change that to bottom center, and we'll see this little blue circle come down to the bottom, and apply and close. And I need to do that for each one of the houses, and you'll see that these move up. So open sprite editor, come down bottom center, make sure that's on there, make sure you hit apply and close, and again it's moving up. Now what I found is that if I put these at about -6, they all kind of look reasonably decent, and they look like they're sort of poking out of the water, showing that it's been flooded. So I think that looks pretty decent. So I'm just going to leave these objects here for now. We're not actually doing anything with them at this stage. It's just for a visual representation so we can see how the game is starting to look. Next, the plane. Now the plane is actually huge. If I drag that into the scene, you can see how big that is. So we obviously need to change the dimensions of that. So again, it's a single sprite. Now this one I found works at 600 PPU. Apply that. I'm going to put that sprite back in. Now this one I'm actually going to use as my object. So I'm going to rename that to plane. I'm going to tag it as the player, and then I'm going to change it so that on the sorting layer it's on the plane sorting layer. I'm also going to position it at -2 on the x-axis, 4 on the y-axis. Lastly, the crate sprite. This one was absolutely huge. So if I drag this in, it takes up almost the whole scene. So on the sprite here, again, it's a single sprite, and I found 1200 was pretty good. Click apply. Now this time I'm going to use this as my actual scene object. Crate. Now this one I'm going to give it a tag. Add tag. And I'm going to tag it with crate, which we're going to need a little bit later on. And also on the sorting layer, that goes onto the crate sorting layer. Now for the moment, I'm not going to try to position it anywhere clever. I'm just going to just sort of leave it floating around for the moment, and we'll come back to that. So at this point, we've got the basic scene set up, so we can kind of have an idea of how the game is going to look. Now, the purpose of this tutorial really is to focus on how different kinds of objects within the game are moved and manipulated. The first one of these we're going to work on is the clouds. Now what I want for these is for the clouds to kind of move across the screen, sort of from the right hand side, and slowly move across to the left. And I want to have a little bit of variation. So I want to randomize the sprites themselves. So recall that this sprite sheet, if I just drag this up, make this a little bigger, we've got various different types of sprites that we can use here. So I'm going to randomly pick from one of these, have a random height, and then have that move across the screen. So what I'm going to do is I'm going to create a 2D object, and I'm just going to use a built-in circle for now, just as a visual representation. And I'm going to call this cloud. Now this appears in the middle of the scene. I actually want to position it over on the right hand side. Now you don't have to have these even numbers like me. I'm just a little bit weird like that. I hate having these weird numbers. So as you can see, this is off on the right hand side of the screen. So when the game starts, this is the game preview, you can't actually see it. So it's not seen at all. Now this I'm going to put on the sorting layer for clouds. And we're going to add a script to this. This is going to be the first one of the scripts we're going to be writing. So create mono behavior script, and I'm just going to call it cloud. Click on my object and drag that script into here. And now I can double click this to edit this in my Visual Studio. I like to do this slightly differently, so I'm just going to delete that and start again. There are 3 things I want to do with the cloud. First of all, I want to grab the sprite renderer and give it a random sprite. This line of code simply initializes a list of sprites to a new list. Because I've used serialized field, this is actually going to appear in the inspector now. So if I click on the cloud object, we'll see here under the script, we've now got this sprite, which is an empty, an empty array. Excuse me, I've got a bit of a cold at the moment, not feeling great. So apologies if I keep coughing. So we've got on here 1, 2, 3, 4, 5, 7 sprites. So let's add 1, 2, 3, 4, 5, enough elements, and then I'm simply going to drag in each sprite, and now I need to get it to actually pick one of these when it starts up. What I'm doing here is I'm grabbing the sprite renderer component so I can access its actual sprite property, and then I'm going to create an index into that list of sprites, and this is simply going to be a number from 0 up until excuse me, 1 minus the length. The random.range is exclusive on the max. So if I do sprites.count, that will go up to 6 and not 7, which is exactly what we want. So then we can simply set the sprite property on the sprite renderer to be the particular sprite that is in our array. Now on its own, this isn't actually going to do anything because we still can't see the cloud object because it's off the screen. So what we also need to do is actually put in some code to have it move over to the left. So this is going to be the first ways in which we move an object. So let me show how I'm going to be moving this particular one. It's just a single line of code. So what we're doing here is we're manipulating the transform object. So if you recall, every single object in Unity has got a transform component. When I say every object, I mean every game object that appears within your hierarchy has a transform component, and that in turn has a position, a rotation, and the scale. So if you manipulate the position, that allows you to move it. What we're doing here is we're using an inbuilt method called translate, and what that does is it will move it along a particular direction vector. Now I'm not going to go into vectors and vector math or anything like that in this tutorial. I want to try and keep it simple and keep it to the actual movement. But the vector2 definition, it has a few shortcuts, one of which is dot left. So what this is doing is simply saying move the object to the left, and then we have to tell it how far to move. So I've declared a variable called speed. I've got this at a very low speed. Now one thing that is important to note here is I'm also factoring in time.delta time. Now what this does, again, I'm only going to give you just a very brief explanation here. Let me know if you want a more detailed look at this in another video. The update function runs on every single frame, and that frame rate, how many frames per second, is going to vary considerably based on what kind of computer this is running on. So I've got quite a beast of a machine here, so I'm going to get a really fast frame rate. But if I was to run this on my old laptop that I had from like 15 years ago, which is a bit of a potato now, it's going to have a much lower frame rate. But we want those clouds to be moving at the same speed on every single computer. And what this delta time does is it's just a little factor that says how much time elapsed since the last frame. And by multiplying our overall speed by this, that simply ensures that we'll get a consistent looking speed across any kind of computer. It's important to note that anytime we're moving something within the update function, we need to use delta time. And I'll show you where we do things differently later on. If I run this now, we'll actually see this start to work. So our little circle here changes into one of the cloud sprites and starts to very, very slowly move across the left of the screen. And just as it pops onto the camera view here, we can actually see this in the game view going across. Now, one thing I'd like to do here is to have some variation in the y-axis. At the moment, this is only moving to the left, and so every cloud is just going to go across this exact same trajectory from where it first started, which was at the y position of 4 that we set when I set up the initial object. So let's do that now. So what I've done here is I've introduced 2 new fields here. We've got a minimum y and a maximum y. I've set those to 1.5 and 4.5. That seems to keep them at the top of the screen, but gives it a little bit of randomization. And this is what we're doing. So now we are directly accessing the position of the transform component, and specifically we're having a look at the Y. So we set the Y position to be a range in between the minimum and the maximum, and then what we're doing here is we're setting the position into a new vector 2. We're keeping the X as it was, and then we're feeding in the new Y position which has been generated from this random. Now we're not going to see a lot of difference initially because we've only got one cloud. When I tried to play that, it didn't seem to make any difference. Reason being, I didn't save the file. You have to save any changes that you make in Visual Studio before it will actually get recompiled on the game. So let's try that again. So this one here, that's coming in as 2.18. 3.89. So now we've got that randomization. But of course, this is just one single cloud. So the next stage is going to be to introduce something that is going to spawn clouds on an interval. Now, the observant amongst you might have noticed that earlier on I created a script in here called Game Manager, which has now disappeared. And the reason for that is as I was starting to record this tutorial, I kept getting these errors in Unity. Turns out that Unity's actually managed to introduce a bug into their new system when they dropped a security update just about a week ago. I've done some videos on this. So I had updated my Unity version about a week ago, and it's since then that I've been having these problems. And this morning it was just really driving me nuts, and I had to get to the bottom of it. I managed to fix it, but what I did is I wanted to delete all of the code in my project just to make sure it wasn't anything to do with anything that I had created. If you're getting any weird errors, go over to my channel, watch this video. It's only 2 minutes long and it just shows you how to fix it. So that is why I don't have a game manager in here. But now I want to create one. So let me do that again. So I'm just going to create a script called Game Manager, which I cannot spell. And I'm going to create an empty object called Game Manager. And then I'm going to assign that script to the object. So this object doesn't actually do anything in the screen. It's not anything that moves. I just tend to move it up just for organization purposes. But now it has a script, and it's this that we need to use to control various things about the game which aren't specific to a particular object. So what I want to use it for here is to be in control of spawning various objects in the scene. So it's going to be spawning the clouds, and later on it's going to be spawning the houses as well. So let's get it to spawn the clouds. So as before, I'm just going to delete that and just start from scratch. So to spawn an object within code, we need to use this method called instantiate. So I've created a method here called spawn cloud, and we need to give it something called a prefab, which I'm going to show you in a moment. So all I'm doing here is in the start method for this particular class, I'm just calling something called invoke repeating. We give it the name of the actual function that we want to call. This is simply a delay, as in start this immediately because it's 0, and then we give it an interval. So what this is going to do is it's going to call this spawn cloud function every interval that I specify here. So for the moment I'm just going to put it on 1 second. So this is in seconds, just so we can see them coming up very, very quickly, just so we can see that it's actually working. But first we need to talk about this thing here, this prefab. What is a prefab? If I come back over here, this cloud that I created is just an object in the scene. I've got no way to access that and say create more of them. Now earlier on I created a folder called prefab. All I need to do is drag this object from my screen into here. Now it doesn't need to be a folder called prefabs. I could call out whatever I want, but it just needs to be somewhere within the assets folder, within the project panel. If you drag anything from your scene into here, it becomes a prefab. Prefab is short for prefabricated object. Now what I can do now is I can actually delete this cloud from the scene. I no longer need it in there because I have it saved in here. But remember that in the code I'm giving the game manager a reference to it. So by doing serialized field, I'm now going to have over here this field over here for the cloud prefab, which is currently set to none. All I need to do is drag that in. So this should now work. Play the game and we're going to see the clouds literally spawning every second. You can see them over here. They're way too fast, but I just wanted to show that they are actually spawning and that they're spawning at different heights. But we've got a problem here. As they're spawning, we've got loads and loads of these clouds spawning. They're filling up the hierarchy. But then what? What happens to them? Where do they go? And the problem is they don't go anywhere. We do need to destroy them. So this is a quick one-liner and something that we can do on the actual cloud object itself. So let me stop that. Now on the cloud object, I can click on that and I can click on the script, or I can just go directly to the scripts. And all I'm going to do is I'm going to ask the cloud object to delete itself after a predetermined amount of time. I've added in two things here. I've created a new variable called lifetime, which is set to 60. So this is in seconds. And then there is a method called destroy. So it takes two things. It's what it should be destroying. So this is the game object, which is tied to this particular instance of this cloud class, and then the lifetime is of course the duration. So what that means is that after 60 seconds it's going to disappear. Now what I'll do is I'll just quickly put this down just to 5, not 50, just to 5, so we can see it in action initially. So these clouds are being spawned every 1 second, and after 5 seconds they should destroy themselves. You can see they're disappearing now. They're not even appearing on the screen. Okay, so what I'm going to do now is I'm going to stop this and we're going to put some more sensible values in here. So this I'm going to put back to 60, and then in my game manager the spawn interval here I'm going to do for 8 seconds, and that's going to cause those clouds to spawn quite slowly across the screen, so you don't really notice them too much, and that's all we need for the clouds. Next, we're going to work on the plane. So what I want to do here is to allow the player to just move it a little bit. I'm just going to give them a little bit of up and down movement. They can move the plane up and down, but not too high. We don't want them flying off the top of the screen, and not too low. We don't want them to bump into the houses or make it too ridiculously easy. But I'm not going to allow movement left and right. I'm going to constrain it within just the y-axis only. So I'm going to create a new script in here. And I'm going to call it plane, put that on the plane object. Okay, let's open this up. I'm going to start here with the update method. We don't need a start for this. What we're going to be doing is I want to take input from the player to allow them to actually press some keys to move the plane and then move. So I could put it all just within the update function, but I prefer to just have two separate functions here. So I have one called handle inputs. Semicolons would be good, and another one called move. Blooming autocorrect. Thank you for that, Visual Studio. So first of all, notice that I've broken out the code into two individual methods, one to handle the actual input and then one to move. And because of that, I'm grabbing a variable here called direction, which I'm saving as a member variable there. Calling it direction, it's a vector2, which many things are in 2D games, and then I use that to actually control the movement. Now, you might see in other tutorials people put all of this stuff directly within the update method, and that works, but personally I just find it more readable to have smaller methods and then to have them named clearly and to have each one have a specific responsibility. So handling the input is literally just reading the input from the player, and movement, the move method is simply doing the movement. So to look at the input, now what I am doing here, I am using the old Unity input system. There is a new way of doing input now, but it is a bit more complicated. So for a game where you want just a very, very simple movement, this is actually easier. All I'm doing here is I'm checking to see if this particular key is being held down. So the W or the up arrow to move upwards, and we simply set the direction to this shortcut here, which is vector2.up. And then similarly, if they are holding the S key or the down arrow, we move down instead. The actual movement, notice that this is different to how I've done it for the clouds. I'm not using the translate method, and instead I'm setting the position part of the transform component directly. The reason that I'm doing it that way is because if I come back to the cloud, we could actually use the translate, because all this does is it moves along a direction vector. And essentially that's what the plane is doing also. The plane is moving either up or down. But the difference here is that we also want to clamp the movement. I want to restrict it to say, do not go any further up than the 2 and do not come any lower down than the 3.5. And it's just a little bit cumbersome to do it with the translate. And plus, I just want to show a different way of basically doing the same kind of thing. But like before, we're factoring in a speed and we're factoring in delta time, because all of this is done from within the update method. We do have to put in the delta time to make sure that the speed of the movement of the plane is uniform across any kind of computer. So the X position stays the same. We don't change that. We are only manipulating the Y. I've just changed this to maximized. If we play the game now, we can see we can now move the plane up and down a little bit. We can't go left or right, and that's all we can do is just go up and down. In this next section, we're going to start working with these houses. So far, all I've done here is I've just created a few sprites and put them manually in the scene, but that isn't actually what we want. We want to create a prefab out of these in the same kind of way as we did with the cloud, but we're going to want a prefab for each individual house, and we need to give it a few more components. So first of all, I'm just going to rename each one of these, because I just don't like how they're named. So I'm just going to give that house 0. I mean, you can call them whatever you want, but I'm just naming them out after the sprite, but just in a way that looks better to my brain. Make sure that you've got that pivot correct that we mentioned earlier on. So what do we want to do here? We want to turn these houses from being just a plain sprite into an actual physics object. The idea of the game is we want to drop these crates onto the roof, but make it just a little bit difficult to do that, so that there's a chance that they could just kind of like bounce off, roll off, miss, and fall into the water, and then they're lost at sea. And the idea of the game is that we try and deliver as many of the crates as possible. So there's 2 things that we need in order to do that. We need something called a collider, and we need a rigid body, and the rigid body controls all of the physics. So I'm going to set up the colliders first of all. Now, Unity has got a whole bunch of different types of colliders for different shapes. Because these are just kind of square buildings, a box collider is all that we need. Make sure that you select the 2D one, not the other one. Now I'm going to just zoom in on my scene over here. The green outline is what determines the shape of the collider. And what the collider means is it's what is going to collide with another object, what is going to signal to Unity that, oh, this object has hit another one. And you'll notice that all of these house sprites have got these little chimneys on top, and I don't actually want to put that in there. Now you can, if you're interested in doing that, you can configure the shape. You would need a different kind of collider. You need a polygon collider and actually have it go around the shape of the chimney, which would make the game more interesting. By all means do that, but I'm going to keep it simple. So if I click this little button over here, and it's the same button as here, this is going to allow me to edit the points. So I'm just going to drag this one down like that, and I'm going to do that for all of them. Before I do that, I'm going to add another component here called the rigid body. So rigid body 2D again, because we don't want a 3D one. Now we are going to change some settings in that a bit later on. I'm just going to leave them where they are for now, just for demonstration purposes. So I'm just going to go through and add colliders to the rest of the houses. I'll do that off camera. You don't need to watch me do all of those. One thing I do just want to point out, on these last 2 houses, we've got a sloping roof. Now, because of the way I've done the box collider, if I leave it as it is like this, you're going to be able to land the crates right on the edge there, which is going to look a little bit strange. And I actually did this when I created this game the first time around. So what I'm going to do is, if I can just see it, I'm just going to turn off the water for a moment to make it easier to edit this. There we go. And I'm just going to drag it in a little bit. So what that'll do is, if the crate kind of lands here, it will just kind of slide off. It's not perfect. Again, this is one of those situations where you kind of want to have a polygon collider and do it better. I'll leave that to you as an exercise. I'm going to do the same thing with the other house. All right, I've turned my water back on. Let's see what happens when we play the game now. Oh, they all sync apart from one. What's happened there? I've actually forgotten to add the rigid body. Okay, so when you add a rigid body onto an object, it turns it into a physics component. And what does physics do? It responds to natural physical forces, one of which, excuse me, is gravity. So by default, the gravity scale on an object will be 1. If I go around and set all these to 0, that is going to fix this problem. So they're not going to sink into the sea. I left that in there just to demonstrate in case you hadn't seen that before. If we press play now, they all stay in place. So now these houses are not affected by gravity, but when we come to do the crate, we definitely do want that to be affected by gravity. So like with the other objects, we're going to have a script for these. So I'm going to create a house script. House, and that's going to have to be put onto each one of these. I'm just going to minimize that just to make it a little bit easier to see, and make sure each one of the houses has got the script. Now the other thing that we need to do is to turn each of these into a prefab. At the moment, all I'm doing is I'm modifying these objects in the scene, but what we're going to want to do is to instantiate them through the code in the same way as we did with the clouds. So I'm going to come up to my prefabs directory, and I'm just going to drag each one of these houses in, and then I'll be able to delete them from the scene, and then we're going to need to put in some spawning code. So I'm just going to take these 5 now and delete them. So what I'm going to do to get them spawning is go back to the game manager. So we've already got some code in here to spawn the clouds, and we're going to do pretty much the same thing for the houses. So the code to spawn the houses is just slightly more complex than the spawn code for the clouds, but still very similar. So because we've got multiple houses, we're going to need a list of the prefabs. We don't just have the one. So I've got that up here, and we're going to need to populate that in the editor like we did with the clouds. Again, excuse my voice. So on the game manager here, we've got the house prefabs, which is a list. We're going to want 5 in there, 3, 4, 5, and we're just going to drag in each one of the prefabs into there. Oops. Okay, now coming back to the code, you might wonder why the selection of the prefab is done over here on the game manager. So it's doing the same thing as we did for the clouds, which is generating a random index, and then it's just grabbing the prefab at that index. Whereas when we did this for the clouds, we did that same kind of code on the cloud object itself. So you might wonder why I'm doing it on the cloud and why I didn't do that, why I can't put this on the house, for example. The reason is it's the instantiation that matters. So the game manager has to instantiate an object. So we're doing the same kind of thing here. We're doing an invoke repeating. We've got the spawn, and it's this line of code we're instantiating the prefab. With the clouds, it's a little bit different because we instantiate a generic cloud. If I come back to the game, the cloud is actually just a circle sprite, if you remember. It's only got one single prefab, and then all we're doing in the code is actually changing the sprite. So we've already got an instantiated object, and we're just changing something about it. But with the houses, we're instantiating a completely different object, a different prefab. So that's why it's here. Now, another thing that is different is that I'm actually specifying a position this time. So the instantiate is different. When we did it for the cloud, we just passed in the prefab and nothing else. But when we're doing it for the house, we're using a different overload of the instantiate method. And this is where we have to pass in a position and then a rotation. There is no rotation for 2D, and so that's why we pass in this quaternion identity. You don't need to worry about that. It's the same kind of thing as a vector to 0. It's just the no rotation, and it doesn't matter anyway for 2D. So why do we pass in a position? Well, we kind of need to do the same thing for a cloud, but the difference here is that, again, I've only got one single object for the cloud, and I manually set the position when I set it up to 12 and 4. I could go and do the same thing for the house prefabs, but if you notice, all of the X positions here are completely different because I just put them willy-nilly in the scene. So what we're doing here in the code is we're just being a little bit more explicit. So it's in the code here that I'm specifying where they are. And really, I probably should do the same thing for the cloud, because if I was to come back to my cloud prefab and change this position, it would completely screw it up, because that's where they would spawn every time. So that's basically the code. We've got the interval is a little bit faster, so I want the house spawning every couple of seconds. Now, the one thing I haven't done yet is actually put in the movement code for the house. So this is where we come to another important section, because we're moving things in a different way. Now, before I start diving into the code here, I've just realized something. At the beginning of this video, I showed you how to do the GitHub integration, and then I've completely forgotten to use it. So when you come over to, when you've got the Git installed, you've got the Solution Explorer here, which shows you the various files, but then you've also got this other tab here, Git Changes, and you can see there's a whole load of stuff in here. We've got all the prefabs here for the house that we've been changing, and of course all the changes for the code. So the way it works is you simply type in a message and press commit. So I'm just going to put on here clouds and plane done, house prefabs set up. Then I press commit all. And then one last thing to do is come up to Git and then push. And we'll just double check that that's actually worked. If we come over to my flood drop, we can now see we've got 3 commits. If I click on that, there's the last little commit that I've just done. And that shows you all of the things which have changed. So 44 files have been changed there. So that's just something to to get into the habit of doing on a regular basis, which I haven't done on this tutorial project. But generally speaking, anytime I do something where I've just made a major change, I'll do a new commit. I like to commit often, because if you make any kind of mistakes and you screw something up and you think, oh my God, what have I done? You can revert back and have a look at how your code was before. All right, so let's get into the house code. So we're going to delete all of this as usual and start over. So some of this code we've already seen before. We're going to destroy the house after a certain lifetime. Because these are moving a lot faster, it's only going to last 10 seconds and they'll go off on the other side of the screen. So that's as it was for the clouds. But the way we're doing the actual movement is different. So what we're doing here is we're grabbing that rigid body component, and then we're doing something called, we're basically moving the linear velocity. We're setting the velocity. So this is very similar to the translate. Now you can see here that I've got a commented outline, and the reason for that is because we can actually do it the other way. If I was to put this in the update function, it will actually move the object, but it will have implications, and I'm going to show you that later on when we come to doing the crates. I want to show you the difference in how it works. So in order to get the rigid body, we just have to do get component. I like to do this in a wake, which is before the start. That's just kind of like a convention. And then all we're doing is we're moving along the left direction vector, and we're putting in the speed. Another important thing to notice, we do not put in the delta time. And the reason is something that I mentioned earlier on in the video. We are doing this as part of the physics engine. This goes into the fixed update, not the update. And because the fixed update runs at a continuous speed, regardless of the computer it's running on, you don't put in the delta time. So if we go over to the game now and see how it's running, and it'd help if I save the file before I do that, we should actually start seeing some houses spawning and appearing in the game. There we go. Here they go. We can move the planes up and down. The last thing now is to start dropping the crates on them. I'm just going to put that focused actually, just to make sure that the houses are being destroyed when they go off the scene. Let's just make that a little bit smaller. See the clouds slowly going, and you'll see these start to disappear after a few seconds. And here they are in the hierarchy, and they're being destroyed after 10 seconds. So that's all we need for the houses for the moment, but we're going to have to go back and make some changes later. But let's turn our attention now to the crates. So to start things off with the crate, what I want is to have a crate kind of positioned just underneath the plane to look like the plane is carrying it. And we can use a child object relationship here to do this. So what I'm going to do first of all, I'm just going to reset the transform of the crate, and it will move into the center of the screen. What I'm going to do now is I'm just going to drag it over to the plane, and then it becomes a child. But have a look at what just happened. The position changed, and that's because this position is now relative to its parent. So if I reset that transform again, it now goes to the center of the plane rather than the center of the scene. So what I'm going to do is I'm just going to adjust this manually to kind of fine tune it. And when I was testing this around, I found that kind of minus 0.3 on both axes worked quite well. And because of the sorting layer of the crates, I've got the plane appearing over the top, so it kind of looks like it's holding it. Now what I'm going to do is this particular crate is just going to be a sprite. I'm not going to be dropping this one. I'm just going to leave it there as kind of like I call it a held crate, and it's just a sprite. But I'm going to create another one now because what I need is an actual prefab. So if I go back to my sprite, I'm just going to drag another one of these onto the scene. This time I will call it crates, and I'll reset the transform just because I like round numbers. And this time, this one, I'm going to make this into the prefab. This is the one that I'm actually going to be dropping. So this one also needs to be on the crates sorting layer. And then it's going to need a script and a few other components. So because this is also going to be a physics object, we're going to need a collider and a rigid body. We've got the rigid body right here. We're going to put that on and then add in a collider. Again, we can just have a box collider, and because this is a square object, it will be just as we want it. If I just click on that, the reason that little button wasn't appearing is because I need to actually double click on the crate there to go into the prefab, and now I can edit the collider. I actually don't need to. This is fine as it is. And if I now just basically click on anything else, just press F to focus back on the camera. So now I've got a crate prefab. So I've got a rigid body, I've got a box collider, and I'm also going to want a script, which guess what I'm going to call it? Crate. And I'll just drag that over. Okay, that's all we need for now. Now what I'm going to do here is I'm actually just going to move this up and play the game, and you'll see that it drops in the same way that the houses did at the beginning, because it's a physics object, and for the crate that's what we want. So now for the code. Now we've got a kind of a design decision to make here. Where does the code go for handling the launching of the crate? I could put it on the game manager, because the problem is we need that crate to be positioned wherever the plane is, and the plane can move up or down, and that's one of the reasons why I allowed the player to move the plane up or down, to introduce this kind of complexity so that I can show it to you. If the plane was static, if the plane didn't actually move, we could just leave the crate as it is in that position and never change it. But instead, we actually need to track the movement of the plane. So what I'm going to do is I'm going to put some code in the plane to handle it. And what that means is that the plane is going to need a reference to the prefab that we've created for the crate. So like before with the other prefabs, I'm going to delete this one from the scene because it's no longer needed. This one is going to stay there for now. So back in the plane class, we've already got a method here called handle input, and what we're going to do is we're just going to extend that a little bit to also look for a button which to launch the crate. I'm just going to do it as the space key. The other thing that I want to do is to put in some kind of control as to when the player can actually drop the crate. So once they've dropped one, I don't want them to be able to say hold down the space button and keep launching new ones. I want there to be a slight delay. So we're going to need a Boolean variable to control whether or not a crate is currently being held. So let me show you the code. It's going to be easier than typing it out. The first thing I've done is I've added two references here, one for the held crate and one for the dropped crate. The plane is going to need to know about both of those. If we come back onto the inspector here, we can see these here. So for the held crate, we're dragging in that child object from the plane itself. But for the dropped crate, that's the prefab that we created. So they're two different things. The held crate is really just the sprites, and the drop crate is a prefab which is going to be instantiated within the code. If I move on to the handle input, I've just added an extra clause here. So I've got a Boolean for holding crate, and I've got a timer which is set to 1F, which represents 1 second. So when the game first starts off, we've got holding crate is true. Now the reason we've got this this reference here is because what we're going to do with this object, if I come I zoom in a bit over here. We're just basically just going to turn it off. We're just going to set it active or inactive, and that's all we're going to do. If I come back into that code. So we're only going to allow the player to actually drop a crate if we're holding one at the moment, and then we're checking to see if the spacebar has been pressed. So I've got a new method in here called drop crate. So the first thing it does is it instantiates a new crate. So we've seen that already. Now the position, this is just literally taking the same position as the held crate. It's always going to be dropped from that exact same place. So we don't need to have any other position. This will always be fixed. It will always be the same. Now we are going to do some rotation actually, but not at the beginning. We'll worry about that later. So then what we're doing on this second line is the held crate. We're now turning that off. So that's going to disappear from the plane. So it looks like it's been dropped. We're setting that Boolean to say false. We're not holding the crate anymore. And we're setting off this timer, create timer. Now for the timer, what we're doing is we're updating that in the update method. So I put in another method in here, update create timer. And what this is doing is if we're actually holding the crate already, so the user doesn't have to be, they don't have to drop it, initially or immediately. They can just be sitting there holding it. And if they're holding it, we don't need to do anything with it. So we just return from that function. It's only if there's sorry, I can't speak. If only if we're not holding a crate that we actually want to deal with a timer. So we simply subtract the delta time. So again, what this is the amount of time since the last frame and the update method, and therefore this one is being executed every single frame. So if that timer reaches 0, then we simply do the reverse. We're going to turn it back on, that sprite, and we're going to set our Boolean to true. So let's see this in action and see if it works. All right, I've got the game running. The crate is there. It stays with the plane as we move it. I can press the space bar to drop it, but oh my god, what's happening? It's making the houses sink. So remember earlier on when I said there's certain things we're going to have to change on the rigid body? This is why. We don't really want the crates to be so heavy that they can actually sink the houses. This is not the desired behavior. Now notice there, if I drop it into the sea, it just disappears. We haven't done anything with the can I do this from here? Yeah. So if you can see here, if I just keep dropping crates, they're not being deleted. They're just adding to the scene, and we haven't got rid of those yet. So we'll deal with that as well later. But first of all, we're going to have to fix the problem with the houses. So on the rigid body, there is a little section in here called constraints, which is not open by default. And what we can do here is we can put some constraints on the way this particular object interacts with the physics system. By default, Unity will just have objects kind of bumping into each other in a way that it thinks is natural. So there's two things that we can do here. Number one, we can freeze the rotation. So if I just play the game again. Now what will happen now is you'll notice it can still sink them. It's still knocking them downwards, but they're not tipping over. So it's an improvement, but it's still not good enough. What we actually want to do here is also freeze the Y position. Now, we can't freeze the X because we're using the rigid body to actually move the house. If we freeze that, it means they're not going to move anymore. So we need to have the X position to be free, but only the Y position. But we're still going to have a problem, but I'm not sure if we'll be able to see it in this demo. Let me see. Okay, I've moved the plane down as far as I can. Now for the straight ones, it's kind of okay. But let me see if I can hit it here. There, did you notice that? On these particular houses, it's just nudging them over to the left very slightly. Let me try it again on this one. Oh, there we go. It nudged it and nudged it again. How do we fix that? So what we can do here is we can play around with the mass. So by default, any rigid body, when you first put it in, it simply has a mass of 1. So for the Unity physics system, all those objects just have the same kind of mass. They behave in the same way. But in actual fact, the crate is obviously much smaller and lighter than the house. So the way to fix this is simply just to give the houses a much higher mass. So I'm just going to set all of these at 100. And now, even if the crates hit it at that angle on the side of the sloping roof, it's not going to budge it. The crate will not have the power to move. Have I missed one? No, all done. Oh, I have missed one, the first one. Okay, let's try this again. There we go. It didn't move. Right, and that's now kind of behaving how we want it. But if we notice, it's rather easy to play. The crates just drop straight down. They don't really move about. It's not exactly hard. And if you've watched any of my previous videos, you'll know that I suck at arcade games, and yet this is ridiculously easy. So we kind of want to do some more work with the physics there to kind of make this a little bit more difficult, a little bit more challenging. Before I do that, there's one other thing that I want to come back to. I mentioned earlier that we can move the houses by using this translate instead of the velocity. So if I just put in here just a regular update function, and then we're going to take this line, put that in there, uncomment it, and instead we're going to comment this one out. We're going to see what difference this makes. All right, so if I play the game now, drop the crates, what's happening here? They're sliding off. They're not actually landing on the houses. They're just continuing to slide. So why is that happening? Let's go back to the code and have a look. Okay, so what is happening here is that when we use the transform translate, or when we do anything with the transform, whether I'm either doing it with translate or if I set the position vector directly, this tells Unity to ignore the physics system. We're saying, no, override physics. I want to ignore you. I'm taking control. I'm going to move the object in my way. When we move something via the velocity, it obeys the laws of physics. And so what is happening here is the crate is a physics object and the house is a physics object. So when we move the house by manipulating the actual rigid body, as opposed to overriding it by manipulating the transform, it behaves like a physics object, and that's why we've done it in that way. So I wanted to leave that in there and to show it, because I think it's just a better demonstration of how that works. So if we just go back to the game again now, I know this is a little bit repetitive, but hopefully it will drum in the difference. This is what I got stuck with. And so now if I drop it again, they'll stay there and move across. They won't slide off. All right, so now let's look into tweaking this crate physics. There's two things that I'm going to do. One of them is I'm going to give the crate a little bit of a bounce. And the second thing is I'm going to give it a little bit of rotation when it's dropped. So for the bounce, I want to add something called a physics material. So from the back into the assets folder here, I'm going to do create. I think I'm in the right place here. 2D and physics material 2D. Notice that I'm doing this within my project folder and not within the game hierarchy. And I'm just going to call this bounce. For a 2D object, it's got simply two values, friction and bounciness. Now, these are the kinds of things that you can kind of like play around with and tweak. All I've done here is I've taken the friction down just a little bit and I've given it just a tiny bit of bounce. Now, if I was doing something like a breakout game, which I actually am working on, I'd want this bounciness at the maximum, which is 1. So this is a value between 0 and 1. So if I play this now, we'll see that when the crates land on the houses, it will just have just a little bit of bounce. Now, on its own, this doesn't do very much, because the reason why this is still so easy is that the crate is a perfect square, and the houses, the box colliders on the houses, are also a perfect rectangle, and it's dropping directly straight down. So there's no difficulty there. So the bounce, we don't even really notice it until we start moving that crate, until we start rotating it. So let's add that next. So at the moment, we haven't done anything with the actual crate object. So what we're going to do is we're just going to give it a little bit of rotation in the start method. So first of all, we're grabbing a reference to the rigid body. We did this before in the awake. And then in the start method, we're doing two different things here. So this first line, this is saying what direction are we going to rotate in. Basically, this line just gives me a value. It's either one way or another way. So it's basically going to be either clockwise or anti-clockwise. There's a number of ways in which you can do this, but I'm just saying any random value, and that will give me a value between 0 and 1. If it's less than 0.5, we're going to give it a direction of 1, and if it's greater than 0.5, a direction of -1. So basically it's just going to flip the direction either way. So that's all that does. And then this one here, we've got a rotation speed. Now these are very, very small numbers. It took me a little bit of experimentation to do this. And this is one of the beautiful things about the physics engine in Unity, is that you can tweak things and completely change the feel of the game. But this is the important line here. So this is another part of the Unity engine, add torque. Now torque is, if you imagine if you've got a screwdriver on a nut and you're kind of like turning it, that's adding torque. You only need to do it once. You don't do it every frame. So that's why it goes just in the start method and not the update method. So what we're doing here is we are moving it in the direction. So this is going to be either clockwise or anti-clockwise, and we're rotating it by a certain speed. So that is a random value between this minimum and maximum. Force impulse. There's a couple of ways we can do it. We can have kind of a smooth sort of force, or the impulse just says kind of give it a kick. And the easiest way to demonstrate this is just to show how it plays out in the game. All right, if I start to drop a crate now, you'll notice it's just a very slight rotation, and it can go either one way or another. It's not much. It's only very slight, but it's just what we need. And with combined now with that bounce, it just makes it that little bit more difficult. So it's still fairly easy. And this is one of those things where you can tweak this to your own liking. Obviously, if we bring the plane down, this is what I was saying before, it actually becomes quite easy to play, especially on the taller houses. It's not much of a challenge. But again, you know, you can play around with this and tweak it to your liking. I need to make it easy for me so that I can play it. So at this point, we've got all of the movement done, all of the physics done. This is kind of working how we want. But what I am going to do is I'm going to finish it up. So we're going to put in some code here to allow you to actually sort of score some points, as it were, or kind of win the game, and to put a UI on just to make it complete. So we've got a complete game here. Before I start working on the next section, I just want to mention a little bug that I found. I noticed that when I start playing the game, if I press the up key when I first start, the plane actually moves down. And the reason is the Y direction is clamped to 3.5, but I actually positioned it at 4 in the scene. I've actually got a slight error here. This is supposed to be 4.5 and not 3.5 to allow it to go a little bit higher up. Just a very simple fix. Well done if you noticed that when you're going through it. So now if I play again, I should be able to move up a little bit. Yeah, just to the top of the screen and down there. That's better. That's what it's supposed to be. So at the moment, we're not actually destroying the crates at all, and that's something that we need to think about. Now, we could do it in the same way as we did with the houses in the clouds and just ask it to destroy itself after amount of time, and that would work. But the problem with that approach is it doesn't allow us to kind of check what the crate has done. What we really want to see is, first of all, has it dropped into the sea? And if not, has it been delivered? So for the sea, this is quite easy because we've already got an object here for the water, and what we can do here is we can add a collider to it. So I'm going to add a box collider. Now notice the size is going to look a bit strange. The size here is looking way, way, way bigger than what we've got here, and the reason is, if you remember from the very beginning of the game, this water sprite was actually a full-sized image, and what we did is we've drawn it in a different way. We've drawn it as kind of a tiled sprite. We've changed it to the draw mode of tiled, and I've also just noticed there is a warning here saying that the tiling might not appear correctly because the sprite is not generated with the full rect. If you get that, what that is on the import over here, we've got this mesh type of tight. I can change that to full rect, press apply, come back over to my water object, and that has disappeared. Doesn't actually make any difference to this particular game, so I'm not entirely sure what that does. But anyway, the reason for the box collider here being so much bigger is because it's going to the original size of the sprite. So I'm going to need to edit that. So I'm going to bring that down. Now, I could actually use a different kind of collider here. It doesn't have to be a box. There's another one called an edge collider, and that's just kind of like a line, and that would work perfectly well here. But I'm just going to use a box collider because that's fine. Now, over on the left-hand side, I'm also going to drag it in a little bit because on the left, I just want to put an area where it's going to be kind of like a win position to say this is where the crate has been delivered to. Now, one other thing I want to do on this box collider is if I leave it as it is, actually, let me show you what happens. If I press play here, we're going to see two things happening. First of all, the houses can't move, and then the crates are dropping on it. An ordinary collider would just behave as a physics object which is solid, and that's not what we want. So there's a very easy way to fix that, and that is that we change the type of collider on here, something called isTrigger. So what we're saying is this isn't actually an object that can be collided with, but we do want to check for a trigger, basically to say something has triggered it, but we're not actually bumping into it. So if I press play again now, the collider will be there, but we won't actually see any difference in the gameplay. So the houses can move as normal, we can drop the crates as normal, everything is fine. So the trigger is useful for when we want to know when we have overlapped with that object, but we don't want it to behave as a physics object. And similarly, we don't want like a rigid body on here because it isn't a rigid body, it's just some water, and we just want to see if it's gone in here. So Unity offers us a method here which is called onTriggerEnter 2D. If I hadn't got that isTrigger checkbox marked, it would be onCollisionEnter 2D. And then this collision object here, which is passed in as a parameter, this is the other object that it's collided with. So we're asking the crate here, what have you collided with? And what we're doing here is we're calling compare tag. So the tag, this is what we set up earlier in the game, and I actually haven't tagged it here. So actually let's try that. So if I just put this on the console and then drop that straight into the sea, there we go, tag water is not defined. So that's given me an error message there. I remember now, it was when I was trying to set up the tags that I got that Unity bug that I mentioned briefly. So I need another tag here. I'm going to call it water, and while I'm at it, I'm going to do another tag, and I'm going to call it delivery zone. That will do, because we want to check to see if it's been delivered as well. So adding the layer is not enough, we have to actually assign it. So I'm now going to put that there into the water. I'm going to clear that error, and now we should be able to see when I put them in here, if I drop the crate, we get a log. Crate was lost at sea. We don't get that if it was delivered, but we also don't know that it was delivered. So that's the next part we have to set up. So what I'm going to do for this is quite simple. I come back to my scene. I'm going to use another collider. Now, a collider doesn't have to be attached to a sprite or any other object. What I can do here is simply create an empty object, and I'm going to call it delivery zone. It doesn't have to be the same name as the tag. I could call it whatever I want to call it, Mickey Mouse or whatever. I'm just going to put in here a box collider. All right, so what I'm going to do is I'm going to position this. I want it kind of above the sea, and I want it on the, whoops, not there. I want to scale it. So I've set this up as -9.5 and 0.5 with a height of 5. So what that means is if the crate enters this zone, we're going to be able to detect a trigger, and so we can update the code accordingly just by extending this part here. I'm just adding in an else clause, and we're checking the tag again to see if it's entered that delivery zone, and then we get a message to say that it was delivered. And now again, I'm just putting this on the debug log at the moment. We still need to create a UI, but for the moment we'll just use the log, and let's just make sure that that is working. So that, oh, it'd help if I could actually play the game now. Now I can't play it. What has happened here? Ah, can you guess what I've done? What's happening here? I've forgotten to mark it as a trigger. So the delivery bay, same issue. On the scene here, this is blocking the movement. So I need to do the same thing, put that down as isTrigger, and now this should work. Okay, so now when this one goes off the left, there we go. Come back over to the console. Crate was delivered successfully. So if I just do a few more of these now. I can't actually play it because I'm trying to look at the log file and I'm doing it on the small screen. So if we lose a few more and see if we can deliver another one, lose one. So now we're getting these messages. Okay, so that's all working now. The last thing to do now is to create some kind of UI so we can actually see this somewhere other than the console log. Okay, just a couple of other little things to note. I'm not sure if I actually mentioned that we've got the destroy in here. So we are actually destroying the crate in both cases here, whether it's hit the water or if it's been delivered. There shouldn't be any case where it doesn't do this because there's nothing else that it can collide with. Now, at the moment, all we're doing is just outputting a message into the log file. We'll worry about that part later. I want to set up the UI first. And the other thing I'm just going to do is I'm just going to commit this again. So we've got here the crate collision logged. Just commit that and push. Okay, so for the UI, Unity currently offers two ways of doing a UI. One of them is quite new and it's called the UI Toolkit. That is quite complex. It's way overkill for such a simple game. It's not something that I'm going to be covering. The other way is creating what's called a canvas. So the way we do this, we just right click on here and we come over to UI. So not the UI toolkit, but the UI, and we just click on canvas. This will create two things. One is the canvas itself and one is the event system. The event system means Windows events. So on the canvas, on the UI, we can do things like put buttons on that the user can click on. So that's the Windows event system kind of automatically needs to hook into that. Now I'm just going to rename that to UI. Now there's one really important thing that I want to show you here with UIs. Because I remember when I first started learning and people would talk about the UI, I got so lost because nobody ever explained this to me. If I put something in this UI, so I'm going to start by just putting in not a 2D object, a UI Text Mesh Pro. Actually, before I do that, I'm just going to put in an image and I'm just going to call it dummy. We can see it on the game screen, but where is it on the scene? If I press F, which means focus, on the UI, suddenly, whoa, where the hell did my game go? There's my image, which I just put in, but where's the game? For some reason, this is a Unity quirk. The UI canvas is absolutely huge compared to the game, which is just this tiny little square down here. When you're mucking around with the UI, you can lose where your game is, but there's a really easy way to do that, and that is just to press F on the camera. If you go to the main camera and then press the F key, it zooms straight in and you're back in the center of your scene. If you come over to the UI and press F on there, it goes back to here. So you can just zoom between one and the other. I wish somebody had told me that at the beginning. Now we don't actually need an image. I'm going to get rid of that. Okay. Now what I do want is some text components, and again this is something that has been updated in recent years. There's two different types of text. We have a legacy text object, which I'm not going to use, and instead the new way is something called Text Mesh Pro. Now when you click on this for the first time on a particular project, you're going to get a pop-up over here, TMP importer. So this thing called Text Mesh Pro, this originally started as a third-party utility and was later integrated into Unity. We need to import something called these TMP essentials. Don't worry, it's literally just a click of one button. It takes just a few moments and it puts a folder within your assets called Text Mesh Pro. Do not worry about this. You don't need the examples and extras unless you actually want to play around with those examples. That's all you need to do. So that's the first one set up. Another thing to mention about the UI is that there are lots of things you can do with regards to scaling and positioning so that the UI will automatically configure itself for different resolutions, but I'm simply not going to cover that in this tutorial. The only one thing that I will change is over here where it says constant pixel size. I'm going to change this to scale with screen size. It comes up with a reference resolution. Notice this suddenly got a whole lot bigger, and that's because it changes to 800 by 600, when what I actually want is full HD, which of course is 1920 by 1080, and that goes back to how it was. This match width or height, I'm not going to explain that in this tutorial. I'm just going to set it to 0.5. There's a lot more to say about the UI, but it's way beyond the scope of this particular tutorial. I just want to get something up and running very quickly just so we can finish the game off. So there are 3 bits of information that I want to convey to the player. Number 1 is how many crates we have available. Secondly, how many have been successfully delivered, and thirdly, how many have been lost at sea. Once all of the crates have been used up, whether they've been lost or delivered, the game is over. Now, the first thing I'm going to do before I do any of that though is I want to change this font. The default font that this starts with, it just looks absolutely pants, and I see so many tutorials where they never change the font, and it drives me nuts because it's really quite simple to do. So at the early part of the tutorial where I was going through the resources, I think I did quickly show you this particular font here. Now you can use any font you like. We're just going to use a TrueType font. All you need to do is to download it, and then you just need to copy it into the new folder that has been put up here under fonts, TextMesh Pro and fonts. So I'm going to do that now. This is now in my directory, bangers.regular. This is my TTF file. But you'll notice that if you try to drag this in over here to the font asset, you can't. It's not allowing you. And the reason is TextMesh Pro doesn't automatically support TrueType fonts by default. What it needs is something called a font asset. Thankfully, this is really simple to set up. So you come up to Window, come down to TextMesh Pro, Font Asset Creator, and we get a little pop-up. The source font, this is now where we can put on our bangers font here. And then all we need to do is click on Generate Font Atlas. It comes up with some stuff on here. Let me just make this window a little bit bigger. And I'm just going to press Save. And I'm just going to save that literally where it is in the fonts directory. Close that out. And now we have this blue thing here, which looks the same as that. And if I drag that in, now we have the new font, and that's all there is to it. So you can use any TrueType font just by doing that. Very simple to do. And now at this point, this is like any kind of like word processor, so we can change the font size, the color, and so forth, the alignment and all of that kind of stuff. All right, so I'm going to make this a little bit bigger, maybe not that big. And I'm going to change it. I'm going to give it a kind of a yellowish color, sort of similar to the plain. But it's going to be a little bit difficult to read on this pale background, especially if it appears underneath or over the top of a cloud. So there's lots of little things that we can add to this. This is what we get with TextMesh Pro. I'm going to use this outline. So if we just click on here, we can see, it's really hard to see actually. So if I kind of zoom in here, make it a bit easier to see. Yeah, I can just kind of give, where's it gone? Just give it a little bit of an outline. I'm going to try about 0.3 like that. That should work okay. All right, now I'm not going to worry about positioning for the moment because I'm going to use something later which is going to allow me to position things a little bit easier. So I'm going to call this one just crates text. And I'm just going to put some dummy text in here, which is just going to be crates. We'll say 20. And then I want 2 more of these. So I'm going to press Control D just to duplicate them. The second one I'm going to have as delivered. And I'm going to have that same text in here. Delivered 0. And then this one is going to be lost. Same thing. Lost 0. Okay, so they're all just sitting on top of each other at the moment. So there's a component called a layout group, which you can add to any kind of UI object. And what you can do here is you can create an empty object just in the same way as you do with the hierarchy. So I'm going to create an object, I'm just going to call scoring, and then I'm going to move my 3 bits of text inside there. So this doesn't do anything at the moment. But what I'm going to do now is I'm going to add a component here. If I just put in layout group, we've got two. We've got one for horizontal and one for vertical. Now you can put things obviously how you like. I'm going to use a layout, a horizontal layout group, and you can see they instantly go out to the edge there. But now I want to just change the way the scoring is set up. So on, is it this one or is it this one? It's this one here, the rect tool. So what I want to do here is just make this bigger. It doesn't really matter at the moment. And then the actual scoring component itself, I only now need to move just this one thing and it just moves them automatically. And then the other thing I'm going to do is you can check various things on here. So I'm just going to set these to the middle and to the right. I kind of want it like right justified. That didn't work. Why did that not work? Because that needs to be on the actual text components. So align these over to the right. Okay, there we go. And then just, oh, I'm on the wrong thing. There we go, a little bit better. It's not perfect. As I said, the point of this video is not to muck around with the UI. We've got something, it looks pretty shit, but it will do the job. But now we need to actually start to populate this with something, because this is just dummy data at the moment. We've now got this UI component over here. And back in our code, we've got this crate object, and we know when something has happened. So we know when we've lost a crate and we know when we've delivered a crate. But how do we update it? So you might think, oh, well, I can just drag, just give the UI, we can just give the crate a reference to the UI component. But that's something that I don't like to do. Generally speaking, with programming in general, you kind of want to keep certain things separate, and you kind of want to have an idea of what object is responsible for what. And so what I would suggest is that a crate object shouldn't necessarily know how it's going to be displayed. That's for the UI to worry about. We kind of want something in the middle. So what I'm going to do here is I'm going to use the game manager. I'm going to have the crate tell the game manager I've been delivered or I've been lost at sea. The game manager is then going to be kind of like a buffer to then interact with the UI. And what it's going to do is it's going to say to the UI, update the number of crates, and then the UI can update itself. Okay, it's going to be easier to kind of show how this works when I actually put the code in. I started off by putting a few variables on here to say how many crates we've got remaining, how many have been delivered, and how many are lost. And then I've created a couple of methods here that can be called crate delivered and crate lost. Note that these are public variables, so the idea here is that it's another object, the actual crate itself, which is going to be calling this method. So at the moment, the crate doesn't have any way of accessing the game manager. Now what you might be tempted to do is to go over to the crate prefab and to put another kind of serialized field on here to give it a reference to the game manager, and that's a perfectly valid way of doing it. But you would have to do that if you're making a bigger game. Generally speaking, you'll quite often have a kind of a manager class that manages lots of different things, and there'll be many objects within the game that need to interact with it. And if they all have to have a reference to it, you've got to make sure that those references are updated. If they ever go null, it breaks everything. It can get a little bit messy. So what I'm going to do instead is I'm going to make the game manager what's called a singleton, which is where there's only one single instance of the game manager class, and then any object within the game can access that instance and call its public variables. Now this is what's called a design pattern. I'm not going to try to explain that on here, but I'm going to say if you haven't heard of a singleton before, or design patterns in fact, I do have a recommendation for you. So there's an excellent book here called Game Programming Patterns, and this is available to read completely free online. You can just click on here, read it here. Several different patterns here. These are all related to games, and over here number 6 we've got the singleton pattern, and this will tell you exactly what it is, how it works, and the code here. I think this is it C# or is it C++? I think it's C++, which is very similar to C#. Anyway, if you know C#, you'll be able to understand it. Singletons are one of those things that is hotly debated within the programming community. I'm not going to get into that now. I'm just going to show you how it's done. It's just a few lines of code. I'm declaring a static property of type game manager, which is called instance. The get method is public and the set method is private. If you don't understand this stuff, if this goes over your head, this is slightly advanced C#. In fact, if any of the C# in this tutorial is going over your head, I highly recommend you go and look up a C# tutorial by Code Monkey. He has done this massive 12-hour tutorial which goes from beginner to advanced, through intermediate and all the way to advanced, and he goes over all of this kind of stuff. So in the awake method, I'm then simply setting the instance, which is this property, to be this, and that means this particular instance of this game manager. So in other words, there's no other way to create another one unless you were to literally go into here and start duplicating this object. Don't do that, that will break everything. Okay, so from here, it means that any other object can now call this instance, and then from there, they can call any public method. So what that now allows me to do is to call this create lost and create delivered from directly within the create class. So I'm calling this directly on the instance of the game manager, and notice I don't have any kind of reference to it in here. And then on the game manager class, I've just added a log message in there, because at the moment we're still not updating the UI at the moment, we're just updating the game manager. You might think this is a bit convoluted, but it's something that is going to help you when you start to get more complex games. You know, I don't want to show you really crappy hacky methods, even though this is just a really simple game. So if I come over to the console and play this now, we should start to see these messages being logged as we go through. Oh, let me just put that down to a smaller version. So there we go. So we're losing them. If I just drop a few kind of randomly, let's see if we can deliver a couple of them. All right, so you can see there, crates remaining, crates lost have been 4, delivered 4, and so forth. So now that we've got that information there, all that's needed to do is to get the game manager to actually update these text objects that we have on our UI. So what I'm going to do now is I'm going to create another script, and I'm literally just going to call it UI, and I'm going to put this on the canvas object. By the way, these warnings here, I don't know what they are. As I said, I have not dived into the UI massively. I don't know what those problems are. I'm just going to close that down for the moment. It doesn't seem to be affecting anything. Okay, but what this script is going to need is going to need access to the individual pieces of text, and we're going to have to set these up as references, and we know how to do that already. We've seen that a few times. Now for Text Mesh Pro, there's two things that you need to note here. One is that it's actually called Text Mesh Pro UGUI. It's a bit of a convoluted class name, and in order to get access to that, you need to import this namespace here, TMP Pro. Once you've done that, you'll be able to access those references. So I've got one for the crates remaining, the crates delivered, creates lost. This one here, I've jumped ahead of myself here, a game over text. I'll come back to that in a minute. So if I come over to my game now, I'm going to come to my UI objects, and I'm going to need to drag these in. So they're literally just being dragged in. Not that one. Oops, has it gone? Delivered, over to delivered, and lost, over to lost. Now I've exposed one single public method called update UI, and this takes in 3 parameters for the values to put in there. So what's happening here is the UI doesn't have any logic. The UI doesn't know what should go in those values. It doesn't know that the crates remaining starts off at 20 or anything like that. It's dumb. All it does is it's responsible for actually changing what's on the screen. The game manager, this is what has the logic. So we're going to put something in here for that game over in a moment. But first of all, we need to actually call this update UI. So what I've done here is I've got a serialized field to have a reference to this new UI class that I've just put in, and I'm going to need to set that over on the game manager like we've done with everything else. So here it is, the UI there. So we need to drag in literally this UI object, and that goes there. And then in the actual code over here, we can now call the update UI once we've delivered a crate and when we've lost a crate. We no longer need those. I'll just take those off just to tidy up the code a little bit. Now you might be wondering, if there's only one UI, and there generally is only, well, that's actually not true. You might have several UIs on a scene. But if there was only one UI, you might say, well, shouldn't I make that a singleton as well? You could, but there's no need. The reason we would make a game manager a singleton is because quite often there'll be multiple different objects within the game that need to interact with it. Now, of course, this particular game, it's super simple. There's only one thing that needs to interact with it, which is the crate. But the UI, we only want one thing interacting with it, which is the game manager. So it's perfectly fine just to give it a direct reference in that way. Okay, so the last thing I need to do now is this game over thing. Where did I put that? Yeah, so on the UI class, I had already put in a text object for game over. All I'm going to do here to keep things really simple is just have it display a big game over text when you lose the game. So let's set that up now. All right, I'm just going to clear that because it bugs me. So on the UI object, I'm going to put another text mesh pro in here. So UI text mesh pro, and this time I'm just going to call this game over, and I'm going to put that in the text here as well. Game over, exclamation mark. I'm going to use the same bangers font that I did before, but I'm going to make this much bigger, say 200 this time, and I'm going to give it that same kind of yellow. We will need to adjust. Oh my god, can't click on it. We'll need to adjust the size. So I've set this to 900 by 200, and I'm just going to center the text. I think that looks okay. Now all I'm going to do for this is I'm just going to turn it off at the beginning of the screen, at the beginning of the game, and then I'm only going to display it at the appropriate time. So for the UI class, this is super simple. It's basically just one line of code. It's simply going to take the game object of that particular piece of text and set it active. This is going to be a public method, and we can call this from the game manager class at the appropriate time. So how are we going to do this? So it's in here. When we do crate delivered or crate lost, we're changing how many crates we've got available. And when this crates remaining comes down to 0, that's when the game is over. So we need to put some kind of check in here. So I'm going to create a new method for this. So it's pretty simple. I've just put in a method here called check for game over. If the crate is less than or equal to 0, it should never be less than. As soon as it gets to 0, it should trigger. We're just going to call that method on the UI class to show game over, and then we're doing something interesting here. Time.timescale equals 0. If you remember from the beginning, we talked about the update method is called every frame. Everything works on this kind of like the concept of time. By setting the timescale to 0, it effectively pauses everything. It just freezes everything. It just freezes the execution. So if I actually play this, now what I'm going to do here is to test this out, I'm going to change this initially to just 4 actually, just so that you don't have to sit there watching me trying to play this and deliver 20 crates, because we'll be here for a couple of minutes and nobody in it wants to see that. So, and we should be able to do this quite simply. I'm just going to make it as easy as possible. There's a little bug there. You should be able to figure out what that is. Oh, did it stay on? Just, there we go. And object reference not set to an instance of an object. What have I done? I have forgotten to set something. I have a feeling I know what it is. Yeah, I never actually set that game over text. So here it is. I didn't drag it in. Let's try that again. It's useful to show. I could edit this out. but it's useful to put it in because it just shows the kind of errors that you can have, and you know, it happens to everybody. Before I do that, I'm just going to fix that little bug. I don't know if you noticed, it still said that there were 20 crates at the beginning, even though I had changed it to 5. And the reason is, when I first put these up, I just put this dummy text in, but it never gets overwritten. So what we actually need to do is we need to call this method here at the beginning as well. So I'm just going to do that in the start method, just to make sure that it's initially set. Okay, so that now correctly says 4 crates. So hopefully I can do these quite quickly. So now we're seeing these things. Actually, let's lose one. Oh, God. More errors. What have I done now? Ah, okay. So the fix that I thought I had fixed, I hadn't. There is a little Unity quirk. When you change something in your inspector whilst the game is actually running, that change is reverting when you stop playing the game. So because I made that change while the game was running, it didn't take effect. So what I need to do is, now that it is actually stopped, now I need to drag in that game over text. I'm going to save it to make sure that change has actually taken effect, and try that again. So again, this is something I could edit out, but I think it's a useful lesson. Okay, we've got 4 crates. Let's lose one, just so we can see that that's oh my God. Okay, I suck. 1, 2. There we go. So we lost 3 of them. We delivered 1. Game is over. And notice everything just pauses. We can't do anything. If I go over to that game manager and I just comment out that line, I'll just show you what it does. Okay, I can do this quickly by just losing the crates. See, it says the game over, but it carries on playing. So that's where that time.timescale is handy. Now there's just one last thing that I need to do. Hopefully you'll guess what it is. I want to go over to my Git. I'm going to commit, and I'm just going to put in here, game is complete. I'm going to commit. I'm going to push that, and we're done with this part. So now that the game is done, what I'm also going to do is publish this game on itch so that you can go and play it. And also I want to link to all of the assets that I've used in here. So if you want to follow along, you'll be able to just download those. And I'm going to provide a link to a download of the scripts as well, in case you don't want to type them all out. So what I'm going to do is, I might as well show you how to build it and publish to itch, as that's also useful. We come up to File and go up to Build Profiles. By default, this has put it in as a Windows project. Now, what that would mean is that someone has to download a Windows executable, which they could then run from their computer. These days, people don't like to download stuff, so I'm going to change this over to a web project instead. You have to click the switch platform. Now, this can take a little while. Got a little warning there saying cannot build player while editor is importing assets or compiling scripts. I'm just going to assume that's a timing issue. So if I close that out, which it's not letting me do. Oh, it's still going. Okay, that was confusing. All right, I'll be back again when it has actually finished. Oh, there we go. All right, let's try that again. So come back up to build profile. So now web is the active one. And what I want to do here is build and run. If I do just build, it will create a folder on my computer, but I won't be able to run it because it needs to kind of create almost like a server to run it locally from the web page. So I'm going to click on build and run. This takes a while. It can take, you know, anywhere from just a few minutes to like half an hour, depending on the speed of your PC. So I will definitely pause while it's doing this part. Now before we do that, we have to give it a folder to put into. So I'm just going to create one here, and I'm going to call it bin, because I'm a little bit old school there. Select folder, and now it's just going to go off and do its thing. So this is the part which is going to take quite a while. Once this is finished, you'll get this Unity web player pop up, and this is running off of a local host. Now this is what I mean when you say you can't do it normally. If you try to just run this file, it won't work. I can also expand here to make this full screen, so that's a good way of testing it, a good way of getting some screenshots. So this all seems to be fine, and this is what I want to now be able to upload to itch. So if I come over to the directory in which the files were created, which was the bin directory, the index is what runs it. But if I try to double click on it, it says fail to download. And this is what it means by you need to have a web server. So you can't just run it locally without doing the build and run. That's why it's useful to be able to have a publishing platform such as Itch to be able to do that. So this is my page. I've already got an account on here. I'm not going to show you how to do that, but what I am going to do is come up to upload a new project. Now what I'll need to do is fill in the title. So if I put in here, it's going to be called Flood Drop, and I'm actually going to put in here tutorial game just to show that's what it is, and then the project URL will be filled in automatically. You can put in a tagline on here. You can put in various kind of things. I don't really need to explain all of this. Now the type of project downloadable. So this is going to be HTML. You're going to have a zip or an HTML file which is played in the browser. I'm going to leave it as released. I don't want nobody trying to pay for it. And then we need to upload something. So coming back to here, I need all of this. So all of these files, and I'm just going to zip these up into I'll just call it bin.zip, and then I'm just going to rename this to flood drop, and then I can upload that file here. Okay, so I've uploaded that file, and what I want here is this file will be played in the browser. That is important. And then there's a few other things that we need to change here. So the size, this is obviously very small. Now if we come back into Unity, I'm going to click here on this player settings, and then from here I'm going to come down to resolution and presentation. Notice we've got two different tabs here. This one is for the Windows version, and this little icon here, this is for the web. And so by default it's going to make this at 960 by 600. You can change how it appears to have the Unity icon or not. I just prefer to leave it on default. But notice these sizes, 960 by 600. So I want to change that to, am I doing that the right way around? I am. Yeah, 960 by 600. But instead of 600, I'm actually going to make this a little bit bigger. And the reason why is because that button, so I'm going to take off this full screen button. You don't want this checked on here. I want to have this a little bit bigger so that it's got the space to show the Unity full screen button. And then I can put a description on here. I'll fill this out off camera. I've written a little description. I've left a space to link to the actual video once it's posted to YouTube. I've listed out all of the assets, and then I'll also add in the zip file for the source code, which I'll add afterwards. For the genre, I've just put in action. There's quite a few that you can choose from here. Whoops. And I've just put in, oh my God, a few little tags here. So AI disclosure, obviously there's no AI used in this. If you're publishing a game which is also available elsewhere, one of the other stores, you can put that on here. This is a custom name, don't really need that for games, and all of this I'll just have as default. I'm going to leave it as draft for now. So if I save and view, it's going to be in the default kind of like white background and the black. Now personally, I just have kind of a colouring that I use for all of my things, which I'm going to apply now. So to change that, I'm just going to do edit theme up here, and then I'm going to change all of these things, which again I'll do off camera. Okay, so this is now consistent with all of my other games, a little bit easier on the eyes. So you can now run it from directly within Itch, and given that extra space, that allows you to have this button from here. So I'm going to grab a screenshot as well, so I can just upload that to the Itch page. So this takes a little while to come up, and then here we go. So I'm just going to play it and grab a screenshot. I've put in a screenshot now. I'm also going to put in a cover image. I could add some other stuff as well, like on the main page I can put a banner at the top. Now there's a really useful page on Itch. I'll need to put this link to this as well in the description somewhere, but this just shows you all the various sizes for the various things that you can put on Itch. Very, very useful page. So I'll put a link to that in there somewhere as well. So I'll need to create a cover image for Canva, and then once I'm ready for this to go, I will down the bottom, where is it, I'll set this to public instead of draft. Obviously I'm not going to do that until everything is actually ready to go, once I've got the YouTube video up, which obviously I'm still recording, and so on. But that's kind of all you really need to know for how to publish to Itch. Okay, I hope you enjoyed that video. This was my first tutorial that I've ever done. Quite frankly, it's a little bit nerve-wracking putting something out there at this point because I'm still learning myself. I'm still a beginner, which is one of the reasons why I wanted to do it. But I really do appreciate your feedback. So if you liked this particular format where I'm making a full game but kind of focusing more on one aspect of it, which in this case was the object movement, let me know if you'd like to see more of that, if there's any kind of aspects of Unity that you're struggling with, that you need help with and would think would benefit from this kind of tutorial, just like a small game made around it. Let me know. And just if there's anything which you don't understand, if there's something which is not working, then please do leave a message in the comments. I will do my best to help you with it as best I can. And that's really all I wanted to say. This has been my first one, so be gentle. I hope you found it useful. Thanks very much for watching. Speak to you next time.